Okay, so, don't look at me like I'm crazy. Quadratic model for the flow experiment, okay? We got depth. Y. We got clock time in ticks, okay? Then we got 5 points, 1, 2, 3, 4, 5. We draw a curve. I'll get my arm out of the way, I can see where the curve might want to go. Okay? We don't try to hit the points. We don't draw a curve. It does this, and then this, and then this, and then this. Okay? We don't try to wobble around to hit the points. Okay? We draw quadratic. We think it's going to be quadratic. Physics predicts it's going to be quadratic. Okay? And if you believe me, which is questionable, you're going to expect it's going to be quadratic. Okay? That's what we're trying to test anyway. Okay? So you draw the curve. You don't try to hit the points, but you try to get as close as possible on the average. Okay? So you draw a curve. As close as possible on the average to your points without changing direction and wobbling around. Make sense? Now, this curve is going to be part of a parabola. Okay? Then you're going to estimate the coordinates of 3 points on the curve. First place, notice that my curve doesn't go through this point, does it? So that point's not going to be 0, 148. Okay, that point's going to be wherever the curve has to be to make sense of the curve. It's probably going to be a little above or below. You don't start with this point and then go. This is just another point. Okay? You do the curve. And we're going to estimate the y-intercept. Okay, so we're going to estimate the coordinates of 3 points. We'll start with the y-intercept because that's going to make what we're going to do a little bit easier. Okay, later on we'll go 3 points that aren't there. And then we don't want 3 points, 1, 2, 3 here. That's not going to give us information that spans the whole range of what we observed, right? But we don't want to try to hit any of these data points. So we're going to tick a point maybe here, then a point maybe here. Okay? Not too close to the data points so you don't get snowed over by the coordinates of the data points. No, you don't get influenced by anything but your smooth curve. Points on the curve. Not data points. Okay? That's real important because I still always see people using data points. If you use a data point, then you're ignoring what all 5 points are telling you about the situation, okay? The data point can have uncertainties. The curve, if it's drawn well, will have less uncertainty than any of the data points, okay? Or less uncertainty than we expect from any data point. You might look up and get a data point that's right on it. So we do this, okay? So let's say this point is 0, 150. And this point, let's say this goes out to about 150, so that's about 45, 80. And let's say this is 120. Okay? After you've drawn your graph and done all this, you can easily make those estimates. You're pretty good at doing that. Okay? Then, You're going to plug your t and y coordinates of each point into this, which is a form of a quadratic function, right? And you're familiar with that. You know how to analyze, you know how to find the vertex, you know how to find slopes on intervals and all that stuff, right? Because, you know, pretty good at that. We're going to get better because we're going to analyze this thing, okay? So the first point is 0, 150. So y is 150, and that's a times 0 squared plus b times 0 plus c. Right? Makes it pretty easy. So already, since this is going to be 0 and this is going to be 0, you know what your c is going to be. Well, then c, of course, is the y-intercept. Okay? Again, we know that. Okay, your second point is 4580. So 80 should equal a times 45 squared plus b times 45 plus c. Your third point is 120. So 120 should equal 100, not, okay, 100 should equal a times 20 squared plus b times 20 plus c. So we've got three equations. This one, and this one. Now your three equations, if you write them out, are 150 equals c. 80 equals, what's 45 squared? It's 40 plus 5 squared, right? 40 squared is 1600, 5 squared is 25, and 2 times 40 times 5 is 400, so it's 2025. Okay, so that's 2025A plus 45B plus C. And I've got this last equation wrong. This is your y coordinate is 20, your t coordinate is 100. So you want to be careful about that. I pretended to make this mistake just so you would see what you don't want to do, okay? Okay, so anyhow, yeah, I didn't pretend, I just wrote it down wrong. So I've got 20 equals 10,000 A plus 100B plus C. Well, that's a set of three simultaneous equations in three unknowns. Okay? And you're going to solve them. We did this early in the semester, so you have to review a little bit. You could look in the packet, that chapter 9 stuff shows you how to solve an equation, a system with two equations and two unknowns, okay? We'll talk about it next time, but I want you to do this for next time. Okay, so we know that C is 150. Since C is 150, we know that, let's just reverse this, we know that 2025A plus 45B plus 150 equals 80, and we know that 10,000A plus 100B plus 150 equals 20. Where'd that 150 come from? Well, that's C. First equation tells you what C is. Now we've got two equations and two unknowns. I'll just do one more step, I'm going to leave you to it. subtract 150 from both sides, you get negative 70 here. And subtract 150 from both sides, you're going to get negative 130 here. Okay? Now, if I multiply this equation by 9 and this equation by 20, the B coefficients are going to be equal. If I subtract this and by, or if I multiply this one by 9 and this one by negative 20, then the B coordinates are going to be equal and opposite. And when I add the equations, I just get A. So I'll give you a little direction on that when I post the assignment. Okay? But that's what you're going to do. Okay? Now, apparently there was a glitch in the homework for the weekend.